These are your instructions. In general, you just need to follow a PowerPoint. Please make sure the sound is turned up on your device so you can hear the narration. On some of the slides, there are instructions for you in the yellow boxes. And don't forget, if a slide asks you for homework, send it in via Show My Homework. And if a slide asks for Educate to be completed, don't forget to do it by the date given.
By the end of this lesson, you should be able to describe what is meant by the stopping distance of a vehicle. You should then be able to estimate how the distance for a vehicle to stop varies with speed and describe the factors that can affect thinking distance. The first thing we should do is consider why is it important that we understand about stopping distances and what happens if you get it wrong. Stop the recording here and have a think. Well, there are a couple of reasons that we should look at stopping distances. One, obviously, if you miscalculate or misjudge your stopping distance, there's some potential dangers. Two, stopping distances are a really good practical example of where we can apply the work that we've been doing on forces to situations in everyday life. Let's start by having a look at this situation. If you have a vehicle traveling along the road and there is an obstruction in the road, in this case a child, the driver will apply the brakes and bring the vehicle to a stop. So let's say he manages to stop it here. This distance that he's covered from when the obstruction first appears to when the vehicle is stopped is called the stopping distance. And it's a definition that you need to remember. The stopping distance is the total distance travelled from when the driver first spots the obstruction to when the car stops. So we can have a look at this idea of stopping distance in a little bit more detail here. When the driver spots an obstruction in the road, his response is not immediate. He has to think about it and decide what action he's going to take. All the time he's thinking, the vehicle continues to move, and that distance that the car covers is called the thinking distance. And this is a definition that we need to learn. The thinking distance is the distance travelled by the car during the driver's reaction time. And reaction time is something that we need to be able to explain as well. The reaction time is the time taken for the driver to spot the obstruction, process that information, make a decision, and apply the brakes. So now we've got the vehicle travelling this distance that we call a thinking distance. Once the driver applies the brakes, again, nothing happens immediately. The vehicle has to come gradually to a stop. And the distance the vehicle covers while it's coming to a stop after the brakes have been applied is called the braking distance. And this is a definition we need to learn as well. The braking distance is the distance the car travels from when the driver applies the brakes to when the car stops. So now you can see the stopping distance is made up of the thinking distance and the braking distance. And normally we write it as a formula, as given here. The stopping distance is equal to the thinking distance plus the braking distance. And a key point to remember from this stage is that the greater the speed, the greater the stopping distance is going to be. So let's have a look at a very simple example. A driver sees a hazard on the road and brakes. His thinking distance is 11 meters and his braking distance is 32 meters. Find his stopping distance. Well, very simply, his total stopping distance is equal to his thinking distance plus his braking distance. Put in our figures, 11 plus 32 meters is 43 meters. So that is his total stopping distance from the point that he sees the hazard, reacts to it, applies the brakes, and the vehicle gradually comes to a stop. For your exam, you need to be able to estimate typical stopping distances for a family car. So from the highway code, here are some stopping distances for 3 common speeds: 30 miles an hour, 50 miles an hour, 70 miles an hour. You should notice that as the speed increases, the total stopping distance increases. And you should also notice that as the speed increases, the part of the stopping distance that increases most is the braking distance. And we'll come back to that and discuss that in our next lesson. Your thinking distance is affected by two main factors. The first one, quite obviously, is your speed. When you react to an obstruction, the faster you're going, the more distance you're going to have covered in the time it takes you to react. So the first factor is how fast you're going. The second factor that you need to understand is your reaction time. This is how quickly you respond, and you need to know how some factors affect your reaction time. So a typical factor is something like tiredness. When you're more tired, you react more slowly. Drugs, alcohol, and a lack of concentration, by which we mean using a mobile phone or having a distracting conversation in the car, also increases your reaction time. If your reaction time increases, your thinking distance increases. The car covers more ground because it's taking you longer to respond. Now, reaction time varies from person to person and with all of those factors that we've already discussed. But a typical reaction time is between about 0.2 and 0.9 seconds. So let's see how that affects our thinking distance. If a car is travelling at 10 meters a second, how far will it travel while you react to a situation in the road if your reaction time is good and if your reaction time is not so good? To work this out, we can use our previously used formula, distance equals speed times time. And if you substitute in the figures, you'll see that if your reaction time is good, your thinking distance is short, about 2 meters, and if your reaction time is not so good, then your thinking distance is quite a bit longer, 9 meters. And you work that out just by using distance equals speed times time. Here's one for you to do. Again, take the reaction time as being between 0.2 and 0.9 seconds. But this time, let's have the car traveling at 30 meters per second, which is 70 miles an hour, and work out what the thinking distance is in each case. So if your reaction time is good, you use the formula distance equals speed times time. This time we're traveling at 30 meters per second, gives us an answer of 6 meters. If your reaction time is not so good, again using distance equals speed times time, this time 30 meters per second times 0.9 seconds gives you a thinking distance of 27 meters. It's important that you remember all of the definitions that we've covered. So, in your book, can you write a definition for stopping distance, thinking distance, and braking distance? And can you list 4 factors that affect thinking distance? The final task from this lesson is to send a picture of your work from this lesson to Mr. Rahman by Friday the 10th. Thank you.